populations. So, in this chapter, organisms and population, we will be learning about just population for now, and I will be taking classes from organisms later. Population. So, what does this consist of? It consists of population attributes. Then we have population growth. Then it has exponential growth, logistic growth, and we have life history variation, population interaction. Then under population interaction we have five major subtopics. So this is what we will be covering. I'm planning to finish it today. Okay, so this chapter is a very uh, long, no, it's a chapter that is easy but with so many examples. Remembering the examples that to organisms is very hard, but okay, yeah, but the first three pages are somewhat good, right? So in nature we rarely find isolated single individuals of any species. Majority of them live in groups in a well-defined geographical area, share or compete for similar resources, potentially interbreed, and thus constitute a population. Although the term interbreeding implies sexual reproduction, a group of individuals resulting from even asexual reproduction also generally is considered a population for the purpose of ecological studies. Okay, so even asexual sexual reproduction, both are considered as a population for the purpose of ecological studies. All the cormorants in a, so I have to just check it out what cormorants are in a wetland. They are a species, okay, and rats in an abandoned dwelling, teak wood trees in a forest tract, bacteria in a culture plate, and lotus in a pond are some examples of a population. In earlier chapters, you have learned that although an individual is the one that has to cope up with a changed environment, it is at the population level that the natural selection operates to evolve the desired traits. So, what does this simply mean? So, when there is a change in the environment, when there is an adverse effect, we generally say that an individual has to cope up, right? But now they're saying that the population level itself has to evolve. It operates to evolve the desired traits. So population ecology is therefore an important area because it links ecology to population growth and evolution. Okay, a population has certain attributes whereas an individual organism does not. An individual may have births and deaths, but a population has birth rates and death rates. So this is one of the population attributes, right? The rates hence expressed are change in numbers, increase or decrease with respect to the members of the population. Here is an example. If in a pond there were 20 lotus plants last year and through reproduction 8 new plants are added, taking the current population to 28. So we calculate the birth rate as 8 by 20. Plants added by plants that were there before, plants that were added divided by the plants that were there earlier, which is 0.4. So 40%, right? So offspring per lotus per year. So 0.4 offspring per lotus per year. So each lotus, for each lotus we are saying, okay, if 4 individuals in a laboratory population of 40 fruit flies die during a specific time interval, say a week, the death rate in the population during that period is 4 by 40, which is equal to 0.1 individuals per fruit fly per week. Okay, so another attribute characteristic of a population is the sex ratio. An individual is either a male or a female, but a population has a sex ratio. So this is the third population attribute. Per capita birth rates and death rates, and per capita rates, per capita births and deaths, and then sex ratio, and we will say about age pyramid. Okay, so a population at any sex ratio, 60% of the population are females and 40% are males. This is one of the examples. Now, a population at any given time is composed of individuals of different ages. If the age distribution per individual of a given age or age group is plotted for the population, the resulting structure is called an age pyramid. So if the age distribution, it's been plotted like this, okay, if it's been plotted like this, then for a human population, then the age pyramids generally show the age distribution of males and females in the in the diagram. So the shape of the pyramids reflecting the growth status of the population, whether it is growing, stable or decline. Okay, so this can be inferred from the age pyramid. Now we will be seeing about the age pyramids for human population. So it can be of three types. With we can determine it. Okay, so we can categorize it, that expanding, stable, declining. So post reproductive period, pre-reproductive period. When the pre-reproductive period is greater than the reproductive period, then it is expand. When it is the same, then it's stable. When it is lesser, then it is declining. This is a very simple way to identify the age pyramid. The size of the population tells us a lot about its status in the habitat. Whatever ecological processes we wish to investigate in a population, be it the outcome of competition with another species. So what they say is, the size of the population tells a lot about what we want to find in the or maybe the status of the habitat. Okay, so whatever ecological process we wish to investigate in a population, be the outcome of a competition with another species